Welcome to Pure Mathematics 1 Functions and Graphs, Video 3, Inverse Functions. We'll start by looking at inverse operations. The inverse of addition is subtraction. The inverse of multiplication is division. The inverse of the trigonometry sine function is inverse sine written as sine to the minus 1. The inverse of the cosine function is written as cos to the minus 1 or inverse cos. The inverse of tangent is written as tan to the minus 1 or inverse tan function. The inverse of square is square root, and the inverse of cube is cube root. The inverse function process. Consider y equals 4x minus 1. This function takes the input x, multiplies it by 4, and then takes away 1 to give y. So if the input is 2, we times by 4 to get 8, take away 1, and the answer is 7. When the input is 4, we times by 4 to get 16, take away 1, that's 15, and so on. And the process is worked from left to right. The inverse function asks the question, what input is required to achieve a desired output? For instance, for me to get 7, what is the input that is required? So working with the diagram again, this time we work in the opposite direction. We reverse the process, in other words. So instead of working from left to right, we work from right to left. And the process is as follows. If we take the y, we reverse the minus 1 function, and we add 1 to the y, we get y add 1. Then we divide that expression by 4 to get y plus 1, all of it divided by 4. And that will give us the x. So we have x equals y plus 1 divided by 4. Now let's try with the numbers. If we start with 7, we add 1, we have 8. 8 divided by 4, the answer is 2. And that checks with what we had before. Let's try another one. 15 add 1 is 16. And the 16 divided by 4 is 4. So that works. So that is how the process is supposed to work. Now I must mention functions must be 1, 1 for an inverse to exist. We can also do this using algebra. We can also find inverse functions using algebra. To find the inverse of a function, y equals f of x, rearrange the equation to make x the subject and then swap the x and y variables in your new equation. First example, find the inverse function of f of x equals 3x minus 1. Let y equals 3x minus 1. Then step 1 is we add 1 to both sides. So we have y plus 1 equals 3x. And then we divide by 3 on both sides to have y plus 1 all divided by 3 equals x. And then finally we swap the x and the y so that we have y equals x plus 1 divided by 3. And we write the final answer as the inverse function of x equals x plus 1 divided by 3. And we can check that this is a 1, 1 function, like the function itself. The inverse function is a 1, 1 function, like the function. So that's fine. Example 2. Find the inverse function of f of x equals x squared plus 4. Again, we let y equal x squared plus 4. Then we take away 4 from both sides to have y minus 4 equals x squared. Taking the square root of both sides gives the square root of y minus 4 equals x. Then we swap the x and the y so that we have y equals square root x minus 4. Now, for this function, it is necessary to choose the positive root and restrict the domain so that an inverse exists. Remember that for an inverse to exist, the function must be 1, 1 function. So in this case, we take the positive root and then we write the inverse function of x as the positive root of x minus 4 such that x is greater than or equal to 4. Thank you very much for listening.